MIT and Harvard engineers create new face mask that can detect COVID-19 infection. Coronavirus detection mask. Architects at MIT and Harvard have planned a model face cover that can analyze the individual wearing the veil with COVID-19 inside around an hour and a half. The innovation can likewise be utilized to plan wearable sensors for an assortment of different microbes or poisonous synthetic substances. Credit: Felice Frankel and MIT News Office. The sensor innovation could likewise be utilized to make clothing that distinguishes an assortment of microorganisms and different dangers. Specialists at MIT and Harvard University have planned a novel face veil that can determine the wearer to have COVID-19 inside around an hour and a half. The veils are installed with little, dispensable sensors that can be fitted into other face covers and could likewise be adjusted to recognize other infections. The sensors depend on freeze-dried cell hardware that the Exploration Group has recently produced for use in paper diagnostics for infections like Ebola and Zika. In another examination, the analysts showed that the sensors could be joined into face covers as well as apparel, for example, sterile garments, possibly offering another approach to screen medical services laborers' openness to an assortment of microbes or different dangers. We've shown that we can freeze-dry a wide scope of manufactured science sensors to identify viral or bacterial nucleic acids, just as poisonous synthetic compounds, including nerve poisons. We imagine that this stage could empower cutting-edge wearable biosensors for people on call, medical services workforce, and military faculty, says James Collins, the Termeer Professor of Medical Engineering and Science in MIT's Institute for Medical Engineering and Science, IMSS, and Department of Biological Engineering and the senior creator of the investigation. The face veil sensors are planned with the goal that they can be initiated by the wearer when they're prepared to play out the test, and the outcomes are just shown within the cover, for client protection. Peter Nguyen, an exploration researcher at Harvard University's Wyss Institute for Biologically Inspired Engineering, and Luis Sengson, a venture builder at MIT's Abdul Latif Jameel Clinic for Machine Learning in Health and a previous postdoc at the Wyss Institute, are the lead creators of the paper, which shows up today in Nature Biotechnology. Wearable sensors. The new wearable sensors and symptomatic face veil depend on innovation that Collins started fostering quite a long while prior. In 2014, he showed that proteins and nucleic acids expected to make engineered quality organizations that respond to explicit objective atoms could be installed into paper, and he utilized this way to deal with make paper diagnostics for the Ebola and Zika infections. In work with Feng Zhang's lab in 2017, Collins fostered another sand cell sensor framework, known as Sherlock, which depends on CRISPR catalysts and permits exceptionally touchy location of nucleic acids. These sand cell circuit segments are freeze-dried and stay stable for a long time, until they are rehydrated. When enacted by water, they can associate with their objective particle, which can be any RNA or DNA succession, just as different sorts of atoms, and produce a sign like an adjustment of shading. Installed viral particle sensors inside mask. Specialists inserted sensors within the cover to distinguish viral particles in the breath of the individual wearing the veil. The veil additionally incorporates a little repository of water that is delivered at the press of a catch when the wearer is prepared to play out the test. Credit: courtesy of the scientists. All the more as of late, Collins and his partners started chipping away at fusing these sensors into materials, fully intent on making a sterile garment for medical services laborers or others with possible openness to microbes. In the first place, Sengson played out a screen of many various sorts of texture, from cotton and polyester to fleece and silk, to discover which may be viable with this sort of sensor. We wound up recognizing a couple that are generally utilized in the design business for making articles of clothing, he says. The one that was the best was a blend of polyester and other engineered strands. To make wearable sensors, the scientists installed their freeze-dried parts into a little segment of this engineered texture, where they are encircled by a ring of silicone elastomer. This compartmentalization keeps the example from dissipating or diffusing away from the sensor. To exhibit the innovation, the analysts made a coat implanted with around 30 of these sensors. They showed that a little sprinkle of fluid containing viral particles, mirroring openness to a tainted patient, can hydrate the freeze-dried cell segments and actuate the sensor. The sensors can be intended to deliver various sorts of signs, including a shading change that can be seen with the unaided eye, or a fluorescent or radiant sign, which can be perused with a handheld spectrometer. The scientists likewise planned a wearable spectrometer that could be incorporated into the texture, where it can peruse the outcomes and remotely communicate them to a cell phone. This gives you a data criticism cycle that can screen your natural openness and alarm you and others about the openness and where it occurred, Nguyen says. A symptomatic face cover. As the specialists were wrapping up their work on the wearable sensors right on time in 2020, COVID-19 started spreading all throughout the planet, so they immediately chose to have a go at utilizing their innovation to make a symptomatic for the SARS-CoV-2 infection. To create their symptomatic face veil, the scientists implanted freeze-dried Sherlock sensors into a paper cover. Likewise with the wearable sensors, the freeze-dried segments are encircled by silicone elastomer. For this situation, the sensors are set within the cover, so they can identify viral particles in the breath of the individual wearing the veil. The cover additionally incorporates a little supply of water that is delivered at the press of a catch when the wearer is prepared to play out the test. This hydrates the freeze-dried parts of the SARS-CoV-2 sensor, which examines gathered breath drops within the veil and creates an outcome inside an hour and a half. This test is just about as delicate as the best quality level, exceptionally touchy PCR tests, yet it's pretty much as quick as the antigen tests that are utilized for speedy investigation of COVID-19, Nguyen says. The models created in this investigation have sensors within the cover to identify a client's status, just as sensors set outwardly of articles of clothing, to distinguish openness from the climate. The scientists can likewise trade in sensors for different microorganisms, including flu, Ebola, and Zika, or sensors they have created to recognize organophosphate nerve specialists. Through these exhibitions we have basically contracted down the usefulness of best-in-class atomic testing offices into a configuration viable with wearable situations across an assortment of uses, Sengson says. The scientists have petitioned for a patent on the innovation and they are presently wanting to work with an organization to additionally foster the sensors. The face veil is undoubtedly the primary application that could be made accessible, Collins says. I think the face veil is presumably the most progressive and the nearest to an item. We have effectively had a ton of premium from outside bunches that might want to take the model endeavors we have and advance them to a supported, advertised item, he says. The exploration was subsidized by the Defense Threat Reduction Agency, the Paul G. Allen Frontiers Group, the Wyss Institute, Johnson & Johnson Innovation JLABS, the Ragon Institute of MGH, MIT and Harvard, and the Patrick J. McGovern Foundation.